Now, let's talk about the bubble sort. This list right here is going to be the example that we're going to use to perform the bubble sort, and we expect it to be in an increasing order after sorting. Now, let's discuss how the bubble sort going to work. The first step is to compare every consecutive pair of numbers, and if the first number is bigger than the second one, then you're going to swap them. So let's see, what do I mean by that? So the first pair going to be 8 and 7, and you can see 8 is greater than 7. So according to algorithms, the first one is bigger, then you're going to swap them. So 7 right here and 8 right here, and I'm going to cross out inside. So now let's find the next consecutive pair, which is right here, which is 8 and 6, and 8 is greater than 6, so you're going to swap them. So your new one going to be 6 and 8. So now let's move to the next consecutive pair, which is 8 and 5, and 8 is greater than 5, so you're going to swap them. It's going to have 5 and 8. And now let's move to the next consecutive pair, but there's nothing here. So what do? So we're going to read the algorithm. It said like you stop comparing when there's no pair to compare. So you can see there's no pair left. So we're going to stop doing comparing thing, and you're going to repeat the algorithms until no pair can be swapped. So we're going to repeat the algorithms, and you can see you stop only when no pair can be swapped, but we just swapped a lot right here. You can see 1 right here, 1 right here, and 1 right here. So we're going to redo the algorithms and comparing from the first pair until the last pair. So now let's solve this problem in a more formal way. On my left side, I have a variable called swap pair to keep tracking how many times that we swap the pair, and another variable right here to keep tracking how many times that we run the algorithms. So this is going to be the first time that we're going to run the algorithms. At the beginning, we're going to have the first pair, which is 8 and 7. So according to the algorithms, if the first number is bigger, then you're going to swap them. So 8 is bigger than 7, I'm going to swap them. So now it's become 7, 8. And the swap pair is updated to 1. Now, let's move to the next consecutive pair, which is 8 and 6. 8 is greater than 6, so you're gonna swap them. Become 6 and 8. The swap pair update to 2. Now, you move to the next pair, which is 8 and 5. So, since 8 is greater than 5, so you're gonna swap them. After swapping, the swap pair update to 3, and it's become 5 and 8 this time. Now, since next to number 8, there's nothing. There's no number right here. Therefore, we're reaching the end. There's no pair left for we to compare. So, you're gonna repeat the algorithms, and since we swap pair for like 3 times, therefore the condition that no pair can be swapped is false, so we can repeat the algorithms. Now you can see we repeat the algorithms, so this is going to be the second time that we run the algorithms. We're going to reset the swap pair to 0. So the first pair going to be 7 6. Yes, 7 is greater than 6, so you're going to swap them, and swap pair update to 1. Continue. 7 to 5 going to be another pair. 7 greater than 5, you're going to swap them. Swap pair update to 2. 7 to 8, but 7 is less than 8, so you don't swap them. And now, next to number 8, there's nothing. So, you're reaching the end, and you're going to repeat the algorithms. The condition that no pair can be swapped is false, because we actually swap pair for 2 times already. So, we're going to run the algorithms for the 3rd time. Now, this is going to be the 3rd time. You can see it's updated right now. Swap pair restart to 0. We're going to start at 6 and 5. And 6 is greater than 5. So we're going to swap them. And now you see the swap pair is updated to 1. Now we move to the next pair. 6 to 7. And 6 is less than 7. You don't swap them. And 7 is less than 8. So you don't swap them. And next to 8, there's nothing left. So reaching the end. And you're going to repeat the algorithms. And the condition no pair can be swapped is wrong, because the swap pair is 1 right now. It's not 0. So we're going to repeat the algorithms for the 4th time. Now, the 4th time, 5 and 6. 5 is less than 6, you don't have to swap. 6 to 7, you don't have to swap because 6 is less than 7. 7 to 8, 7 is less than 8, you don't have to swap them. So now, next to number 8, you can see there's no number. Therefore, you're going to stop comparing. And now, you're going to consider if you repeat the algorithms or not. But you see this time, the swap pair is equal to 0. Therefore, the condition, no pair can be swapped, is true. So, you stop the algorithms. Therefore, your algorithm's gonna stop during the 4th time. So this is gonna be the summary of what we just did. And we also want to find the runtime of the bubble sort. As you can see, this is the summary of the 4 times that we run the algorithms. And for each time, the machine compare every consecutive pair, every consecutive pair, every consecutive pair, in order to put each element into a right position. Same thing on the 2nd time, same thing for the 3rd time, same thing for the 4th time. Therefore, the runtime gonna depend on how many times the machine compare every consecutive pair, every consecutive pair, every consecutive pair. And if you notice, the box with a black border gonna represent the pair. So we only focus on the entire box with the black border, not just single yellow box. Therefore, the summation of all the box with a black border gonna be your runtime. So in this case, for the first time, there are 3 boxes with a black border, which means 3 pair. Similarly, for the 2nd time, it's gonna be 3 pair as well, because there are 3 black border box. For the 3rd time, 3 as well, because there are 3 black border box. 4th time, 3 black border box, gonna be 3 times again. So your runtime gonna be 4 times 3, which is 12. So how to write this thing in more general form? And if you can see, number 4 right here actually represent for how many times you run the algorithms. And since our list initially has a length of 4, so the list with 4 length take at most 4 times to generate the algorithms. So the list of n element is take n times to generate the algorithms. So number 4 right here kind of represent for the length of the list. So I'm gonna put n right here. How about 3? 3 represent for the number of pair. You can see the first time is compare 3 pair, 1, 2, 3. So I have 3 right here, and the rest have the similar thing. So for the list of 4 element, there are 3 pair. So you can speculate the list of 5 element gonna have 4 pair. The list of 6 element gonna have 5 pair. You can add more on the list and you can check on your own. Therefore, the length of n element gonna have n minus 1 pair. So number 3 right here, I can represent it at n minus 1. Therefore, your general case gonna be n times n minus 1. And if you distribute, it's gonna be n squared minus n. And as n goes to infinity, your runtime gonna be O n squared.